There are some changes in the values, the delta. People ran and then found some fluctuation solution, so I examined it and changed the values. So XY values are okay, but delta T was not small enough. I thought 4 is good, 4 was good enough, but it turned out to be unstable. So I reduced this by half, and then I changed this value. I didn't change this value, but I used the same value, but I found that this same value was used here, so I changed this value, delta T and T. So in your program, the only change required is maybe this delta T or the end value of T. And I used these deltas, but you don't have to use these deltas because you already programmed something here. You already programmed something here. You may use these delta values, delta T values. And here we have delta values and delta T value. And here there is no upper bound. So you may animate like 10 frames or 20 frames. You can decide the number. So these are the minor changes. So in your program, you may need to change delta T mostly, right? Delta T to be stable. And in my previous one was 1. It was too slow. So I used 5. And then I changed the end value of T. Any questions? Then we have about 3.5 more sessions to cover. Of course, each day we have 2 sessions, but this is the planning. Already half is used here. So for the second half, I will finalize the theory of FEM and begin to mention about the actual design of the programs. In other words, FEM isn't just a piecemeal programming stuff. It requires some ideas and nice design. So I'll talk about design and some ideas. And 20th, we will cover programming related or algorithm related stuff of FEM. So I will let you know how to program this kind of thing. Of course, this method is not unique. So it is my method. It's not something that is standard or in the textbook. Just I developed this method. You may develop better method. But I'm giving you at least one idea of FEM. And 27th, about 20 minutes will be used for FCQ. And then the remaining portion will be used for FEM-related programming. And here we consider the outline and design part and a few necessary functionalities required in this thing. And 27th is all real programming, actual programming, right? So it is real code stuff. So you may ask questions. I can let you know how to code this or how to code that. But it doesn't mean you just type what I wrote down. It doesn't mean that. You should understand the idea of these things and really program yourself. And question and answer. And this May day, I don't remember, 3rd or 2nd, 4th, thank you. when it is used for the review of the whole course. So from like we handle the number conversion, right? Number conversion and numerical analysis and ODE, right? And then PDE and especially FDM, FEM. So we will review everything. So this is the plan, and if you have any questions, ask me. Of course, if you can completely design these things and then program, you don't even have to attend these 2 sessions. But as I mentioned before, FEM is just a piecemeal thing. You can easily do it by thinking overnight. You need nice design ideas and then really program these things. And in addition, there is no standard. You may program this way or that way. Nobody knows what may be better. Of course, in the future, someone may find a very efficient method, and then it can be a textbook case. But right now, we don't have any textbook case. So I created one, and then I will let you know my design. And you may get a hint, and then you may develop your own things. So as I mentioned before, these 2 days will be used for design and implementation ideas of FEM. Why? Because this course is not about theories. We cover very, very limited theories, but it is practically programming everything to solve problems. And FEM can be easily covered in 1 session, theoretically, but it doesn't mean you can really program these things. I should let you know how to really design and program these things. Any questions? Then finalization of the theory part, and then we begin the design ideas. So I typed the necessary stuffs, and let's use these things. First of all, we use Galerkin's approximation idea. So we minimize the error of the function and this result, right? So we minimize the error, and then we want to determine C by minimizing this idea, and we can create a weak form and then solve this instead of this. In other words, these two are mathematically different, but this idea minimizes this error, right? This error. And the goal is determination of this C. Once we determine C, we can find the solution. And under this assumption, we design, if this is in some sense design idea, we create basis functions. So basis functions are designed and then labeled this way. Oh, first one is the first interior point, second interior point, and up to L interior point. So we find all the interior points, and then we define phi function for the boundaries. And boundaries are given usually, right? Because of this reason, determination of coefficients related to the boundaries is not difficult. You can just use boundary. For instance, if you have some basis function here, assuming that this rectangle is a boundary, then to determine C, for instance, 100, you can just use the boundary condition and then calculate the height using the boundary condition and then assign the boundary value. So it's not very difficult to determine the boundary value. So determine this coefficient using the boundary value. So in some sense, you can do it anytime, right? Just have a basis function, and then we just determine C value using the boundary value given by the problem. Then boundary determines the coefficient. Then we can break up the solution sum into 2 parts, interior parts and then boundary parts. So I used 1 to L, right? 1 to L, interior parts, and boundary parts. Interior parts and then boundary parts. Then now we return back to the differential equation, and then instead of using u, I replace u by this sum, right? This sum, right? So I replace u by this sum later. But before going in further, we use integration by parts, or generalization of integration by parts called Green's first identity. We have these two functions multiply, then we integrate, right? We integrate, and then we differentiate this. So this is the idea. And then we can calculate this thing, and then because this is the this function is considered for the values L running from K running from 1 to L. We are considering these things with this limited K, right? With this limited K. These functions are all 0 on the boundary. So on this boundary, these are all zeros, right? This function becomes 0. So if we integrate this part, it becomes 0. So essentially, the differential equation becomes this one minus g, this one, right? So this is all we wrote down. And then if we now replace u by the sum, right? U by the sum given here. U by the sum given here. Then you can get this identity, and we can simplify further. And last time when I simplified, I just used the sigma expression, and then I missed the boundary part because I just used the sigma without. So I found that these are necessary, and this should move to the right-hand side later. In any case, we can write it this way, and then you can multiply these things and write it this way, right? You can multiply these things, you can do the dot product of these things and write it this way. And then we can change the finite sum and the integral, right? Finite sum and integral this way, and then you can write. So essentially rewriting the stuffs. And if you have any questions, ask me. And then we continue. Then we have this thing, and then we move all the terms to the right-hand side to get this one. And then, for simplicity, we do not use this double integral all the way through. We just call this kind of thing AKJ. So we have K here, J here, right? AKJ. Then the left-hand side, and then we call this thing BJ. Why? Because it only depends on J here. And then here, K is used to sum, right? So once sum is done, K doesn't appear anymore. So only thing that changes is J. So it's called BJ. Of course, this part can be called AKJ with appropriate numbers, right? Appropriate K, right? K running from L plus 1 to L. In any case, we can abbreviate these things. Then essentially what happens is this one. AKJ multiplied by CK with this sum. With this sum is the left-hand side. And then the right-hand side is BJ. And then this kind of equality holds for J running from 1 to L. Do you follow me? So if we write it in matrix form, A11, A1, A, J is changing, K is multiplied here, A21. So if I write it in matrix form, let's write it. So if we write the stuffs in matrix form, so this is the matrix that we obtain, K running from 1 to L, and then J running from 1 to L. So let's write one line at a time. Assume that J is equal to 1. if we assume that j is equal to 1, then what happens is this one. A 1 C1 plus A 2 C two, A 3 C3 and so on, plus A L1 CL equals B1, right? So this is the first line. And then you can write more lines, right? You can write more lines. And then the last line is 1A, 1L, C1, right? And A 2L, C2, and all the way through. And then ALL, CL equals BL, right? So we can write it this way, and then we can create a matrix form. B1, B2, BL. C1, C2, CL, and then A11, A21, A31, and so on, right? And then A1L, and then AL. So this is the. So essentially, we can determine these coefficients by solving this system. And as you can see, to create this kind of system, you need to determine AI and then BI, right? Generally AIJ and BI. Then as you can see, we create the system like this, right? System like this, and then we solve this system for C, right? Unknown this C. So we can essentially solve this C, and then after solving this for C, we can use these C values to these P values to find the solution. So essentially, steps are these. We create basis functions covering the domain, right? Having height 1 here, having height 1 here, having height 1 here, or having height 1, 1, 1, 1, 1, 1. And then these kind of functions are created, and then boundaries, and then we now determine C. So C1 could be, for instance, 10. C2 could be 0. C3 could be minus 1. C4 could be 2, right? So C changes. Then essentially what you have is a solution surface. Any questions? And as you can see, when we defined phi, when you defined this thing, is AKJ the same as AJK or not? Look at the definition part. They are the same, right? They are the same. So because of this reason, this matrix is symmetric. This matrix is symmetric. So you don't have to find all these things in actual calculation. In actual calculation, because it's symmetric, I will use transpose instead of saying A11 and A21. I will say A12 in general representation, right? I will use one because they are the same. We usually represent matrix this. So all we need is this kind of thing, A13, and then A1L, and then A22, A23, and then A2L, and then A33, and then A3L, and then all the way through ALL. And once we determine these things, we can use symmetry to determine this lower part, right? This part can be determined easily. And then we just do not stop here. We can go a little bit further to calculate, for instance, A1L plus 1. In other words, boundary related A can be calculated too, right? Do you follow me? This is not theory part, but in practical calculation, we can calculate A11, A21, A1L, and then we can go all the way to A1L, right? A1N, capital N, right? So we can calculate everything in this matrix. So we calculate these many stuffs, right? So this is used for theory part. This is used for practical part, right? Boundary integration, right? Boundary integration is all used or calculated the same way. Once we know how to calculate Aij, then we can calculate all these things. Something used for theory, something used for boundary. All the same way we can determine. And then after determining, using these things, we determine Bj, right? Using these things, we determine Bj. So this is the step. So take a look. We initially create the basis functions, right? We initially create the basis functions like these. Right? So we create the basis functions, and on the boundary, we already know C values, right? So boundary, for instance, C0 or C1 is already known, right? 1.2, right? And then we know the boundary of Cn, 1.5. We know the boundary values. And then these boundary values combined with Aij after this L boundary, we can add these things to determine Bj, like the formula. As you can see, we can add these kind of things, calculate, and then by attaching known Ck using the boundary values, right? Ck using the boundary values, and then multiply these together to create Bj. Do you follow me? Great. Then, what part is tough? Of course, as I mentioned, the programming and design of this whole thing isn't very trivial. Theoretically, we can cover these things in 1 hour, but practically, really programming these things require many, many things. So please browse the idea part and check whether you can obtain all the values theoretically at least. And then we design. So please check it. So boundaries, and then these are separated, right? Boundaries and interior basis functions are separated for convenience. And then we determine the coefficients of the boundary by using boundary conditions given by the problem, right? So we know the boundary conditions. And then we break up this basis function times coefficient into two parts, boundary parts and interior parts. Boundary parts are already determined. So we determine interior parts. And then afterwards, we calculate the integral like this, right? We calculate the integral like this. For any combination, for any kj, right? For any kj, we can do this. Of course, I will let you know how to do it. And then afterwards, we create the matrix. We create a matrix of this part, right? We create the matrix of this part. We create the matrix of this part. And then, after creating this thing, we copy this thing, right? We copy this thing because it's symmetric, right? We copy this thing here. So we create the whole matrix of this part, right? And then, practical calculation doesn't just stop inside this triangle, but it goes further to calculate everything necessary to determine D. In other words, by doing these things, we recycle these things to calculate B part, right? Then take a look. Coefficient matrix is created, right? The constant part is created, then we can solve this system, right? We can solve this system for C, and then after solving this system for C, we assemble the solution, right? We assemble the solution by using this. So this is, so theoretically, 10 minutes are enough to explain. But practical programming is the key. If we just cover these things in theory, why should we even spend any time? Just 10 minutes are enough. But because we are really programming these things, we need to know necessary steps and the theories together. Of course, theory part is completely explained, but we need to know how to really design this. So please browse the idea of this and then theory part and ask questions. If you don't, then I will begin to mention about the idea of really programming these steps. Yes. The differential equation may have some function on the right, plus an equation. G is a function. So for instance, this could be 0 function. This could be, for instance, sine x or sine x plus y or something. It's just general G function. So I will just, you may browse the notes or you may browse these things and questions. I will reduce the size so that you can check all the parts. This means 0 on the boundary, right? For the explanation, I just used this kind of notation, but this is not necessary. And this minus can cancel that. So for instance, if you really program the stuff, then you will get this kind of result. And I will let you know how to do these kind of things about using 2.5 sessions. So where is my lab? It's very slow. I should have used smaller NNM. I thought my computer was slow, but this computer might be very slow. It's my mistake. I should have used 10 instead of 100. So 100 by 100, and then triangles mean 20,000 triangles I used. Too many triangles. So it is my mistake. Control C? Yeah. I'm learning MATLAB. Sure, we could stop it. So I will reduce the size. Right, now it's 200. So roughly, you can find a solution like this using FEM. So we can change the triangle shape using, for instance, 20 points instead of, or even 50 Let's be very careful. So we can find the solution using these kind of things. So one thing at a time. To show you what kind of things are necessary, I will, oh, by the way, there are many questions about problems. I used something submitted already. Some students finished it, so I used some students' code to show you the solution behavior. There were 2 things you need to solve on homework 7, right? So I will use this idea. So this is the heat equation, right? Heat equation. And this is the wave equation. So assume that we have some kind of E shape on top of the water, and then we somehow keep the shape, and then suddenly remove, then what will happen? Then we can see it. Let's do it one more time. So what I used was like some value, some recycled value, but let's not worry about the actual thing. So someone already finished and got the perfect script. It's not mine. In any case, let's really design the stuffs. But one thing, even small thing, could be very tough to really handle. So I will show you the problem. When we design these kind of things, it's not a rectangular shape, it's a triangular shape. So I'm making it a little bit more general than necessary, because in our case, our triangles look like this, right? Look like this. But let's make it more general. In other words, assume that we have a triangle like this. In other words, we have x1, y1, x2, y2, x3, y3. Of course, when you see the figure and then when you sketch, then we may know something is inside the rectangle or not, right? Inside the rectangle or not. But programming this thing is not easy. So this is the difference between the theory and actual implementation. Theoretically, we may say that, oh, the point should be inside the rectangle. Program it. In other words, how can you check whether x, y is inside this rectangle or not? This kind of thing is difficult, right? Even if theoretically I can say, oh, the point should be located inside the rectangle, practically implementing it isn't easy. Of course, when you have this kind of very nice shape, we can use a rectangle idea to do it, but I make it a little bit more general than necessary. Can you solve it? So please think of this for like 1 minute and let me know your ideas. Do you have any ideas? Especially, it is like geometry blind. In other words, you just have numbers. How many numbers? Total 8 numbers, right? Assume that 8 numbers are plugged in. Then your algorithm should determine whether it's inside or not. Of course, we include a boundary. We include.
We'll take those 8, or we'll start with those 6 numbers to make 3 inequalities.
Uh-huh.
You can use an inequality pretty easily, and you can nip an inequality.
How?
Well,
How can you?
Okay, so what would be the line between one of the 2 points?
Of course, yeah. Of course, geometrically we can say a line and the stuff. But what I want is this one. 8 numbers are plugged in. Your program do something and then pops out the result. In other words, it's inside or outside. That's what I mean. In other words, of course, geometrically we say, oh, the point should be above the line.
Well, yeah, and that's what we use our inequality for. So say we've got a line, if we have y is greater than mx plus b, where mx plus b is whatever the line that goes through there, then it's going to describe that half
Right,
plane.
right.
Well, you have to say, well, is it greater than this one? Is it
Right.
And so you've got three if statements that tells us if it satisfies all
Yeah.
three of those, then
Yeah.
it's in. Otherwise, it's out.
Yeah. But what I mean is this one. With geometry, it's obvious, right? With geometry. But what I mean is really programming those things. In other words, we may have, for instance, we expected this kind of equality, this kind of equation of the line, or right? We may expect, right? But assume that somehow it is a vertical line. Then can you have A? Somehow we have a vertical line. Can you have an A? We may have vertical line like this, right? In other words, the difficulty is not geometry or idea part, but really implementing it. In other words, A numbers are plugged in at random. We don't know what the shape of the triangle is, but assume that we want to really program something. This is the difficulty. So theoretically, we can say, oh, to be inside, it's easy. It should be above this line. If it's, and then below this. Theoretically, it's not very tough. But practically, programming. So I will give you the idea. The idea is this. Of course, you may have better idea than this one, but any idea is okay. As far as this works, I will say inside the triangle function, has 4 points, right? P representing xy, and then 0.1, 0.2, 0.3 representing vertices, right? So it has this. Of course, P has two values, right? Each P has two values, xy, x1, y1, and so on. Then, once we call this function, the return value should be true or false, right? True or false. In other words, if it's inside, it should return 1. If it's outside, it should return 0. Or if you have other programming language, you may use true, false, or something. So this is the idea generally used, and so P1 is somewhere, right? We don't know where P2 is, but let's say somewhere P2. And then P3 could be anywhere, so let's just say P3. Then what we do is this one. Assume that something is inside, then this line, and then this one can be product with cross product. Then it represents this factor multiplied by this should be upper direction, right? And then the next thing is this vector cross product, this vector should be also upper direction. And then this vector, P3 to P1 vector, and then this vector should be upper direction. In other words, the direction should be upper or lower. So let's consider the other case. Somehow P3 could be here, right? Then if it is inside, then P1, P2 vector, and then this vector, right? P vector should be lower. And then similarly, P2, P3 vector, and then P2, P vector should be low, right? And then P3, P1 vector, and then this. So I decided to use this idea. Then it's nothing but cross product calculation.
Basically, you're assuming that that point is within the plane of P1, P2, P3.
Of course, we are handling the planar domain, right? So every point is in the plane, but I'm introducing third dimension, right? The z dimension, to use the idea. In other words, if it is inside, then the cross product should point the same direction, right? Upper or lower, or lower or upper. But assume that this is violated. In other words, the point is outside. Then what happens? Assume that the point is outside, then what happens? Assume that the point is outside, then what happens is this one. P1, P2, and then P1, P cross product points downstairs. Do you follow me? And then P2, P3, and then P2, P direction is also downside. Now, P3, P1, just a moment, P2, 3. Oh, it should be upside. I was confused. This should be upside. Sorry. This should be upside. Do you follow me? Right thumb rule, right? Right thumb rule says P3, P2, P3 vector, and then P2, P vector should be upside. So as you can see, this cross product goes down, the other product goes up. In other words, there is discrepancy, right? Then it is not inside. In other words, to be inside or to be outside, it should have the same sign or 0. 0 is representing the boundary, right? It touched the boundary. So 0 is okay. But if it has opposite sign, then it cannot be in the triangle. So this is the idea. Then, once we have this idea, instead of inequality, it's not very difficult to program. So I will let you know the idea of this program. So generally, for convenience, we define P4. We define P4, and then P4 is nothing but P1, right? Because we want to create a cycle, right? Then P1, P2, P3 cycle. And then after P3, return back P1. But in program, returning back to P1 isn't easy, so I just create one more point, P4. So you don't plug in P4, but our program copy this thing in P4. Then we define the sine function using this determinant. So how can you do sine? I will do this thing. So this is the idea. P1, P2 vector can be represented, right? So similarly, Pi plus 1 vector can be created, right? So what is it? This vector is nothing but Pi plus 1 and then x part, right? I will use dot x, like object-oriented programming skill. I will use dot x, or comma x is okay. Represent the x coordinate, right? Minus Pi x. This represents the difference of x coordinate. And then Pi plus 1 y coordinate minus Pi y coordinate. So I create this thing for I from 1 to 3, right? 1, 2, 3. So please browse the idea. In other words, we are creating the vector P1 to P2, P2 to P3, P3 to P4 or P1. So we create 3 vectors. The only thing remaining is what? I will create one more thing. Pi to P vector should be created, right? Pi to then it is nothing but Pi plus Pix this P, right? This Px vector minus Pix. And then this Py minus Piy. So we can run this thing inside the loop, right? We can run this thing inside the loop to create 6 vectors. Do you follow me? So we create 6 vectors. The only thing remaining now is the cross product. So let's do the cross product. We have every point inside the 2-dimensional plane. So we consider the cross product of these things. Pi plus 1 vector, cross product P vector. But as you can see, it's two-dimensional vector, and then it cannot be cross producted, so I will intentionally attach this thing. So we call this 2 bar, and then this, by definition, this thing, right, this thing coming, and then 0 cross product, this thing coming, and then 0 product. Do you follow me? So we create two vectors, and we want to embed these things inside the three-dimensional space, right? Two-dimensional plane is embedded inside three-dimensional plane by attaching z coordinates. Then, by the definition of this cross product, it is I hat, j hat, and then k hat, and then these things with 0, 0 here, right? Because 0, 0, and then this coordinate, and this is pi plus 1 x minus pix, right? And then this is px minus pix. And then this is pi plus 1 y minus pix y. And then py minus piy. So I calculate this thing. Then it's not very difficult to do the cofactor expansion about this column, right? Then it is nothing but k vector times this determinant, right? This determinant. So I will write the determinant pi plus 1x minus pix multiplied by py minus piy, and then minus these things replaced by y, right? Or I mean, I will write it. Pi plus 1 y, piy, and then px minus pix, right? X and y are switched. So just once we do this thing, program automatically runs these things, right? So I'm just giving you the idea. And very unfortunately, we don't have enough space, so I will go to the next page. But roughly, this is it. This coefficient determines the direction, right? If this is plus, then everything should be plus. If this is minus, everything should be minus. So this is the coefficient part. So all the things up to this point are, in some sense, unnecessary. The only thing that you should remember is this part. So actual programming is not very tough. So theory looks tough, but once we program it, will be very easy. So I will call the coefficient of k vector in the direction, call this S1, right? So I will call S1, indicating S1 is equal to the coefficient, right? Then it is pi plus 1 x minus pix multiplied by py minus piy minus because I used I, sorry for this thing, I will call this S sub I because this is generic. Then pi plus 1 y minus piy px minus pix. This is called SI, and then we run this for I from 1, 2, 3. So forget about all the things. Just you have 4 points, 4 input points, right? P, 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 right? 4 input points. Then you calculate SI. And then after calculating SI, you check the sign. So S1, S2, S3 should have the same sign or 0. Then it's in the triangle. If it's not, then it's not in the triangle. How can you check it? It's not very difficult. Multiply S1 and S2. Multiply S1 and S2. And if it is minus, then false, right? Then false, right? In other words, it's not inside the triangle. If this is plus, then check the second thing. S2 and S3 is this, then it is false, right? But if somehow it passes both conditions, in other words, S1, S2, multiply this greater than or equal to 0, and then this is also greater than or equal to 0, then the only way possible is everything is greater than or equal to 0. In other words, everything has the same direction. So programming part is extremely simple. Once you program, you create P1, P2, P3 are given. So you create P4 position, and then create SI, right? By looping it. So you create 3 numbers, and then check the sign. How? Multiply 2 numbers, 1 and 2, and then 2 and 3. And then you can return 4. If both things fail, then it means it is inside. So as you can see, it doesn't require any knowledge about geometry or something. Just simple number calculation will determine whether the point is inside or not. So as you can see, if you really program this thing, how long will it take in MATLAB or Maple? Other than just bookkeeping, maybe about, essential line will be about 10 lines, right? 10 lines will be enough to determine whether a point is inside a triangle or not. So please browse the idea and ask questions.
P is on the boundary of the triangle. What does this algorithm do? One cross product will then be 0.
Yeah, 0 is okay. So that's the reason why false condition doesn't include 0.
Is that point considered inside or outside?
With 1 point we cannot determine, but with 2 we can determine. For instance, look at this. Good question. So assume that some point is on the boundary or extension of the boundary, right? So in this direction, it is on the boundary, right? In this direction, it is on the boundary, right? But in other direction, it cannot be. In other words, all these things cannot be 0. The worst condition might be 2 numbers become 0, right? Then on this line, it is on the other line, it is 0. But then automatically it is on the triangle because we include the boundary. In other words, if 2 of these numbers are 0, then it automatically is on the boundary. But as you can see, it doesn't hurt. 0 will not violate the condition. So roughly bookkeeping thing, right? Bookkeeping thing, determining S, and then 3-line condition will determine no matter what complicated triangles are given. So with this, you can later determine whether the point is in the triangle or not, or even boundary is okay. Why do I cover this thing? Then I will let you know. Assume that you solve the differential equation, and then I will pause so that you can at least write down. Assume that, so let's use real example instead of just describing the situation. So I can't calculate many things, so I will just consider this thing. So P1 function has 1 here at this position. right? Phi1 function is 1, and then surrounding point 0, and then all other place 0. Phi2 function is 1 here, and surrounding point 0. Do you follow? It's like pyramid, right? It is 1 here, and then what about, so let's say 0.1 here, 0.2 here, 0.3 here, and then 0.1 here, 0 here. And assume that we want to find the value about at this point. That is the question, right? That is the question. So assume that you found the result, phi1, and then this is the solution. Assume that you have found the solution. Assume that you have found the solution. 3phi1 plus 2phi2 is the solution to your differential equation. Then, what is the value of this function at the point that I plot? What is the value? So let's make it a little bit easier to consider. Initially, let's consider the point at the line. Then it's way easier. So about this point, this position is about 0.15, right? So what is the value of this function when xy equals 0.15 and y value is 0.1? Of course, this is not very difficult. Using your intuition, you can determine it. 3 here, 2 here, and the middle. Then what is your guess? This value should be what? 3 here, 2 here, and the middle. Right. It is 2.5, right? It should be 2.5. Do you follow me? Because it is 3 here. Height here is 3. Height here is 3. Height here is 2. And it is connected by a straight line. Then the middle point should have. This point is not difficult, but what about this point? Or what about a point a little bit up or down? So this kind of thing is the task. So to determine these kinds of things, you should check where the point is. In other words, point is inside this triangle or that triangle. Do you follow me? So I'm just covering the first step. We are creating basis functions. Then you should really define the basis functions, because once you have found all the coefficients, you should know the value at points. So we should know this kind of value. But here we use our intuition, but in real program, you should program this thing. In other words, your program runs and then determines this value. So let's do it. This point, 0.15 and 0.1 belongs to this triangle, right? Right? This point is on this triangle, or the bottom doesn't matter. So we now know that the point is here. Of course, if we use the point a little bit above this one, then it is obviously inside this triangle, or above, a little bit below this thing, then it is inside the other triangle. So we should locate the appropriate triangle for the given point. Then how can you determine it? Use the formula that I provide, right? Use this formula that I provide. Then the next step is actual calculation on this or inside this triangle. How can you really define a function inside this triangle? In other words, how can you define phi1 function inside this triangle or phi2 function inside this triangle? Do you know what I mean? So inside this triangle, phi1 function has 1 here, right? 1 here, and then 0 here. Phi2 function has 1 here, and then 0 here. So how can you define these two functions? That is the next task. So as I mentioned, theoretically I can just wave hands and then explain all things within 10 minutes. But practically, these things are involved. So let's do it. So I will use the summary here, and instead of covering too much, I will cover the calculation part of the theory. Of course, you can regard this as theory, but at the same time, it's practical calculation. To do it, we are using the center, called barycenter, of the triangle. So when we have a pen, then we can find the center, right? So barycenter of a triangle can be found. And then we can use midpoint rule to calculate the value of a triangle over the given, for instance, triangle or domain, whole domain. So assume the triangle is given. Then to integrate, we don't really integrate. We just multiply the area of the triangle, right? Multiply the area of the triangle by the barycenter value, right? Value of the function at the barycenter. Value of the function at the barycenter. And then we ignore this kind of error. So this is the one we will use. And then now we have 3 points involved, right? Triangle has 3 points. Then we can calculate the determinant, and half of this determinant determines what? The area of the triangle. If we uniformly divide the domain, then this kind of calculation is very easy because area is constant, right? Area is constant throughout the whole domain. So the only thing that you need to calculate is just the calculation at the barycenter of the function. So it's very trivial. Now, I mentioned this thing last time. Assume that we have a triangle with 3 vertices, x1, y1, x2, y2. So we have triangle with 3 vertices. And then phi1 has 1 at this vertex and 0 at other vertices. So 1 here and other vertices 0. Then we can find the a plus b x plus cy representing this function. This function can be represented by this formula. I derived the formula using just simple Kramer's rule. And then, because we can find the gradient of this one by partial differentiation, we can write the gradient. Take a look. If we take the partial derivative with respect to x, it is b, right? It is b, and then b is here, and then b is written here. And if we consider the partial derivative of this with respect to y, it is c, and then c is here. So we can find the gradient of phi1. And then, now, these kind of things are involved in actual calculation of determination of a, y, j. Then take a look. When you do this thing, then it is straightforward calculation of this thing, right? We can just consider the dot product of this thing, and then this dot this one, and then this dot this one, and then do the calculation. So if you have a question up to this point, ask me. And also, we can make this thing by shifting I position, right? Because phi2 has 1 at 2, right? Phi2 has 1 at 2, not here. So we shift I and j, the indices to create this kind of thing, and then to the dot product, and then calculate. And what about this one? We want to calculate the multiple of these things. When you have integration, what do? Do we really integrate or use midpoint rule? So what is the midpoint of f? F of this is the midpoint, right? What is the midpoint of phi1? Barycenter. Barycenter of phi1 is what? Barycenter of phi1 is what? Right? Phi1 of barycenter is 1. And then phi2 of barycenter is 1/3. So the result is this multiplied by the barycenter, right? The value at the barycenter of this one, right? And then the value of this one at the barycenter. So this one, and then this one, and then area of the triangle d over 2. So we multiply these. Do you follow me or not? Look at this. Look at this. We use this formula, right? We use this formula. Area multiplied by f of barycenter, right? Area of this domain or triangle multiplied by this. So area of this triangle is d over 2. D over 2 multiplied by this function calculated at the barycenter, and then this function phi1 calculated at the barycenter, phi2 calculated at the barycenter. So what is this result? 1/3, right? What is the result? 1/3. And what is this result? Here. And then D. So this is it. What about the next one? F calculated at the very center. And then phi calculated at the very center is what? 1/3. And then triangle area D/2 multiplied together to get this. So please browse this part. Then, assuming that if you don't understand this, the next time you question me, then I will re-answer. But if you still have questions, ask now. Then let's use this fact. In other words, by using this, we can determine the plane inside the triangle, right? We can determine the equation of the plane inside this triangle, representing this triangle. So let's do it. So remember these things. x2, y3, y2, x3, and these things. So let's use these things to determine the P1 function. So inside this triangle, we have, this triangle has 0.1, 0.1. And this is 0.2, 0.1, and this is 0.2, 0.2. Do you follow me? So this is the triangle after our design. Of course, next time I will really design these things and show you what is going on. And then I want to find the P1 function having 1, right? P1 function having 1 here. P1 function. So P1 function equals A1 plus B1x plus C1y, right? So once we determine A1, B1, C1, then we can find the result. So let's do it. Then A1 equals, of course, calculating D might help. So D is equal to 2 times triangle area, right? Area of triangle, or triangle area equals D/2. Let's really calculate it instead of just using the result. So it is 0.1, 0.1, 0.2, 0.1, 0.2, 0.2, and we can do this calculation by subtraction of the first row from the second and third. And then do the cofactor expansion over this row and over this row, then we will get eventually 0.1 multiplied by 0.1. So it is 0.01, right? So D is found. Simple determinant calculation. But throughout the whole domain, all the triangles have these values, right? Essentially. So D is found. And now, to determine A1, what is necessary? A1 can be determined by this formula. This formula, right? So A1 equals x2, x3, x2, y3, 0.2 multiplied by 0.2 minus 0.1 multiplied by 0.2. And then divide by this determinant, 0.01. Do you follow me? I just did hand calculation of the formula. Then, after this calculation, you do have 2. Please calculate B and C. B and C. I will show you the formula. I used this formula to determine A. So please use this formula to determine B and C. So I hand calculate this thing. In other words, phi1 function inside this triangle will be determined. So by this calculation, phi1 function equals phi1 of xy equals 2 minus 10x plus 0y, right? Or this, right? So 2 minus 10x is the function. 2 minus 10x is the function. Then let's calculate phi1 of 0.15, 0.1. What is this? What is this number? So does it make sense? Here, it is 1, right? And then the other node, it should be 0. And the half point should have height what? 1/2. So we found the function phi1. Can you find phi2 too? Can you find phi2? Then phi2 may have some form, right? So we can multiply this result by 3, then it is 1.5, right? And then it is 2 times, it is half position, right? 2 times half position, 0.5, then it is 1, then add 2.5. So eventually we get the result 2.5 at the specific point, but what is the difference? This covers the whole triangle, not just one specific point, right? It covers whole triangle. So we essentially covered it, but I don't want to cover too many things. So please try to master this next time. I will really show you how to design, in other words, how to break up, and then how to create the surrounding triangles, and so on. I will use northeast, east, northeast, and so on, this kind of thing. Next.